All right, today we're going to dive deep into the fight against one of the deadliest diseases for men, advanced prostate cancer. We're breaking down a brand new, revolutionary playbook for treatment, and it's all based on a major scientific review that's looking ahead to 2025. So let's get right into it.
So to really get where we're headed, we first have to understand the core problem, the one that's been stumping scientists and doctors for decades. Why is this disease, once it really starts to spread, so incredibly tough to stop?
Well, the answer is kind of simple, but also incredibly complicated. The cancer learns. You see, at first, the treatments we have, therapies that block male hormones, which are basically the cancer's favorite food, they work really well. But the cancer cells, they evolve. They figure out ways around the drugs. They become resistant, and they start growing again. And that's when things get really dangerous. That's when we call it metastatic, castration-resistant prostate cancer, or mCRPC.
But right there, that's where the story is starting to change. Scientists are finally moving away from that old one-size-fits-all approach. The new playbook, it's all about being smarter than the cancer. It's all about personalization.
This slide really captures the huge shift that's happening. The old way was like using a sledgehammer, treating every cancer based on what stage it was at. But the new approach, it's called molecular stratification. It's about reading a tumor's specific genetic code to find its Achilles heel. It's about finding the exact right weapon for that tumor's specific weakness. This is true precision medicine.
Okay, so let's jump into the first major strategy in this new playbook. Finding much smarter ways to starve the cancer's engine. I mean, literally cutting off the fuel it needs to survive and grow.
You see, the main engine for prostate cancer is something called the androgen receptor pathway. Just think of the androgen receptor, or AR, as the ignition switch in a car. Male hormones are the key that turns the engine on, and when it's on, the cancer cell just grows and divides. For decades, our best drugs have worked by just blocking that switch.
But remember, the cancer is smart. It adapts. It comes up with these really clever ways to fight back. For example, it'll just make thousands of extra copies of that receptor, making it easier to find fuel. Or it'll create mutated versions of the switch that are just stuck in the on position, no key needed.
So yeah, just blocking the receptor, that's not always enough. The new counterattack is a whole new class of drugs called AR degraders, and they are exactly what they sound like. They don't just block the switch, they hunt down the androgen receptor and completely destroy it, taking it out of the equation entirely. In early trials for these drugs, they're showing some really promising results.
Now, this next strategy, this is where things get really futuristic. If starving the engine is like cutting the fuel line, this next approach is like deploying tiny guided missiles and smart bombs that hunt down cancer cells wherever they are in the body.
First up, we've got radioligand therapy. Here's how this incredible seek and destroy mission works. Scientists take a molecule that's basically programmed to find a specific protein on the surface of prostate cancer cells. The most famous one is called PSMA. Then they attach a tiny radioactive particle to it. The molecule acts like a heat-seeking missile, delivering that radioactive payload directly to the cancer cell to kill it, while leaving most of the healthy tissue alone. It's amazing.
And the power of this approach is just, well, look at the results. One advanced version of this therapy got a PSA response, that's a key sign the cancer is shrinking, in over 65% of patients. And these were patients whose cancers had already stopped responding to other treatments. That's a truly remarkable number.
Okay, another type of these precision strikes is something called an antibody-drug conjugate, or ADC. And honestly, the best way to think of this is as a biological smart bomb. It's got two parts: a super-specific antibody that's the guidance system, and a really powerful chemotherapy drug that's the payload, or the warhead.
And the way it works is just so elegant in its precision. First, the antibody finds its target protein on the cancer cell and latches on tight. The cancer cell, not knowing any better, just pulls the whole thing inside, and once it's in, boom! The toxic payload is released, killing the cancer cell from the inside out. It's an unbelievably effective way to get a powerful poison exactly where it needs to go, and only where it needs to go.
This third precision strategy, it might be one of the cleverest of them all. It's a class of drugs called PARP inhibitors. They work on this principle called synthetic lethality. So here's the idea. Some cancer cells, especially ones with mutations in genes like BRCA, already have a broken main system for repairing their DNA. They're just barely getting by using a backup system. Well, PARP inhibitors come in and they take out that backup system, leaving the cancer cell with absolutely no way to fix itself. So it just self-destructs.
And this right here is the perfect illustration of why that molecular testing we talked about is so important. PARP inhibitors are a total game changer, but only for the right patient. They work incredibly well against tumors that have those specific DNA repair flaws, like a BRCA2 mutation. But they don't do much for tumors that don't. You have to know your enemy's weakness to exploit it.
Okay, now for our fourth major front in this war, unleashing the body's own defenses. You know, our immune system is the most powerful cancer-fighting force on the planet, but cancers are masters of disguise. This new strategy is all about ripping off that disguise so the immune system can finally see the enemy and do its job. Now, for a long time, standard immunotherapies like checkpoint inhibitors, they just haven't worked very well for most men with prostate cancer. The tumors are often called immunologically cold. But, and this is a huge but, just like with the PARP inhibitors, scientists found that for a small, specific group of patients that you can identify with biomarkers, these drugs aren't just good, they're a miracle.
I mean, this chart says it all. For the general population of men with advanced prostate cancer, the response rates to a drug like pembrolizumab are pretty low, around 5%. But if you find tumors with a specific genetic flaw, it's called mismatch repair deficiency, or DMMR, the response rate just skyrockets to over 40%. That's the power of biomarkers, finding the right patient for the right drug.
But what if you could just force the immune system to attack, even against those cold tumors? Well, that's the incredible idea behind T-cell engagers. These are amazing molecules that act like a cellular matchmaker. One arm of the antibody grabs onto a T-cell, our immune system soldier, and the other arm grabs onto a protein on the cancer cell. By physically yanking them together, it forces the T-cell to recognize and kill the cancer cell. It's a truly revolutionary idea that's showing a lot of promise.
So we've covered a lot, right? Starving the engine, precision missile strikes, and unleashing the immune system. What does all of this mean for the future of the fight against advanced prostate cancer?
Well, it means the toolbox for fighting this disease is expanding at a breathtaking speed. We now have multiple, completely different strategies. We can go after the fuel supply, we can deliver targeted payloads like a smart bomb, or we can turn the body's own immune system into an assassin.
And the path forward isn't about finding one single magic bullet. It's about being strategic. It's about using those biomarkers to guide every single treatment decision, combining these different therapies to attack the cancer from multiple angles at once, and even going after the dormant persister cells that can cause a relapse. The ultimate goal here is to turn what was once a death sentence into a manageable chronic disease.
And hey, don't just take my word for it. The authors of the scientific review put it this way themselves. The pace of innovation isn't just slowing down, it's accelerating. The next 10 years are going to bring even more transformative changes to how we treat this disease.
Which really leaves us with this final, thought-provoking question. We've gone from using blunt instruments to using molecular scalpels. And with this rapidly expanding toolbox of personalized weapons, we're not just fighting the disease anymore, we're outsmarting it. And for the first time, the idea of a truly personalized cure for many, many patients might not be science fiction anymore.